Okay, guys, yeah. All right, so hello, guys. Hello. I hope you're well. We are actually going to just push for a little bit here. Yeah, this is grade 8 slash grade 9 revision recap for term 1 work so that let us go back at least with some sort of like knowledge. I just do want to let you know that if you miss anything here, YouTube channel, on my channel there, I have a beautiful, all of the videos that I'm doing here, I'm actually posting up on the YouTube channel. If you want to know the YouTube channel, link is in my bio, guys. For instance, I uploaded yesterday's video. It should actually be reflecting only tomorrow, right? It's just on a delayed sort of like upload, but yeah, it should be reflecting tomorrow. So the whole objective or the whole goal is to actually just revise or recap on grade 8 work done in term 1 so that people can go back with power, Right, so let's look at this, right? Yesterday we were doing a lot of like ladder method related type questions, and also in conjunction with that, just those ladder method type based questions, we were doing a lot of like by inspection. No, not a lot of by inspection. We also looked at LCM and HCF. Now we are going to look at LCM and HCF, but not using ladder method or anything like that. We are going to just simply write down the LCM and the HCF by inspection, meaning you are just going to use your beautiful mind and write down what the LCM and the HCF are of the numbers that are going to be in front of you. Okay, so let's take this one step at a time. Write down the LCM. Remember, LCM means lowest common multiple, and then HCF means highest common factor. So I want you guys to tell me what is the highest common factor and the lowest common multiple of 1 and 5. Let's start with the highest common factor. What is the highest common factor of 1 and 5? Just off the top of your head. No use of calculator, just off the top of your head, because this is a skill that learners need to know how to have. Because if you can't tell me what the LCM and the HCF are off the top of your head, it means that come grade 10, guys, and I'm sorry to say, come grade 10, you're going to have a tough time. All right. So one of the skills we need to have is to be able to know what the HCF and the LCM are of two numbers. So let's start with the highest common factor. Between 1 and 5, what is the highest common factor between 1 and 5? Comment section, guys. Let's use it. I see there's 3 people already in the live. KB, I can see you there. Thank you so much for your comment. You're the highest common factor. Remember, you want the number that is the highest, that is common between 1 and 5. Okay, Gift Luyandisa is also saying 5. So we have KB and Luyandisa who are saying that the highest common factor between 1 and 5 is 5, because we just want to state the lowest common multiple and the highest common factor by inspection, not by using any method. So between 1 and 5, are we all agreed that the highest number that 1 and 5 goes into, the highest number that 1 and 5 go into, that is common for both these numbers? I'm saying goes into. That's not true. Sorry guys, that's not true actually. When we talk about highest common factor mouse, we are talking about the highest number that that goes into 1 and that goes into 5. We want the highest number that goes into 1 and also goes into 5 at the same time. The highest number that goes into 1 and that goes into 5. That's what the highest common factor will be. So if you think about it practically, if I write down what are the factors of 1, the factors of 1 are 1. If I write down what are the factors of 5, the factors of 5 are 1 and 5. So between 1 and 5, what is the highest common factor? It will definitely have to be what? It would have to be 1, guys, not 5. Okay? The highest common factor between 1 and 5 is 1. Okay? Then let's go to the lowest common multiple. What is the lowest common multiple between 1 and 5? What do we mean by lowest common multiple? We mean what multiple of 1 and 5 is the lowest, but is common to both of these numbers. Okay, so if you count in ones and you count in fives, the lowest number that is basically a multiple of 1 and 5, but is common to both. So the multiples of 1, you see now we are changing the scenario. Do you remember when we were talking about highest common factor, we wrote down the factors of 1 and 5 and we identified the factor that is common, which is 1. Okay, but now when we say lowest common multiple of 1 and 5, multiples of 1, 1, 2, 3, 4, 5, multiples of 5, 5, 10. Which one, guys? Which one? Okay, these are the multiples of 1, these are the multiples of 5. What is the lowest common multiple? Okay, it is 5. Okay, so be careful, guys. Be very careful. Be very, very careful. All right. So do you see the difference? Because initially I asked you what is the highest common factor between 1 and 5? KB and let's see who it was. Luyanda, they said it was 5. They said the highest common factor is 5. All right, which was incorrect. So do you guys see the difference between what is your HCF and your LCM? Let's look at 2 and 3. What is the highest? Let's start with the highest common factor. What is the highest common factor between 2 and 3? The highest number that goes into 2 and goes into 3. The highest number that goes into 2 and goes into 3. Okay. We have no chungus. The only one answering there saying it's 1. Okay. Yeah, and you've got a point there, my guy. You've got a point there. Okay. So once again, the factors of 2 are 1 and 2. The factors of 3 are 1 and 3. So what is the highest common factor? It is 1, guys. Lowest common multiple. What is the lowest common multiple between 2 and 3? Lowest common multiple between 2 and 3. Now we are focusing on multiples. What are the multiples of 2? What are the multiples of 3? What is the lowest number that goes into 2? What is the lowest number that we arrive at when we count in 2s and 3s? Lowest common multiple of 2 and 3. Okay, lowest common multiple is, if you count in 2s, 2, 4, 6. If you count in 3s, 3, 6. Which one is the common, but is the lowest multiple that is common? It is 6, guys. Okay, let's move on. What is the highest common factor of 6 and 12? Highest common factor of 6 and 12. So you need to know the factors of 6 and you need to know the factors of 12 in order to be able to know what the highest common factor is. Okay. Highest common factor between 6 and 12. Okay. I can see there your answer. Very quick. Okay, there's still people who are doing the whole cricket at this stage. Highest common factor between 6 and 12, good people? Highest common factor between 6 and 12. So it's still no Chungu alone who's basically given me the answer. Although some of us are still getting into the swing of things, still trying to get into the game. Yeah, I hate the fact that some people think it's a good day today to do crickets. Yeah. Okay, Gift is also saying it's 6. The highest common factor between 6 and 12. Right. So once again, what are the factors of 6? 1, 6, 2, 3. Factors of 12. 1, 12, 2, 6, 3, 4. So if we look at what is the highest common factor, 1 and 1, very low. 2 and 2, still low. 3 and 3, still low. 6 and 6, seems like we don't have more than your 6, which is common for your highest common factor. So your highest common factor truly is 6. Okay, remember guys, we're supposed to do this by inspection. When they say by inspection, it means it should actually literally come from you. It should come from the mind. It should come from the mind and heart. Okay, so the highest common factor between 6 and 12 is 6. Lowest common multiple. What is the lowest common multiple between 6 and 12? You count in 6s, you count in 12s. What is the lowest common multiple between 6 and 12? Lowest common multiple between 6 and 12. Lochung is saying it's 12. KB is also saying it's 12. Okay, it seems like we have a 2-part contribution of 12. Okay, so if you count in 6s, 6, 12. If you count in 12s, 12, 24. So basically you can see the immediate lowest common multiple. Okay, if you count in 6s, you arrive at 12. If you count in 12s, you're starting off with 12. So the lowest common multiple is 12. So between 6 and 12, your lowest common multiple is 12. Let's move on. Highest common factor between 5 and 25. What is the highest common factor by inspection between 5 and 25? What is the highest number that goes into 5 and 25? Okay, remember by factor, we are saying a number that goes into another one without leaving a remainder. If they say highest common factor, then we are looking for that factor that is common to both 5 and 25, which is the highest. Which one is that one? What is the highest common factor? So Gift is saying it's 5, Nolchung is saying it's 5. Okay. So yeah, factors of 5, 1 and 5. Factors of 25, 1 goes with 25, and then 5 goes with 5. So the highest common factor is definitely going to be 5, no doubt. Highest common factor between 5 and 25 is 5. Okay, so please guys, if you've forgotten, in your head you should run through what are the factors of 5, the numbers that go into 5. There's only 2 of them, 1 and 5. What are the factors of 25? Okay, it's 1, 25, 5 with 5. Then what is the highest common factor between 5 and 25? It's evidently going to be 5. Okay, what is the lowest common multiple? LCM. What is the lowest common multiple between 5 and 25? The lowest common multiple. Remember, now we are going to be thinking about the multiples, not the factors anymore. Multiples of 5, multiples of 25. We're looking for the lowest common multiple between 5 and 25. What is it going to be, guys? The lowest common multiple between 5 and 25. Lowest common multiple between 5 and 25. Lowest common multiple between 5 and 25. So KB, I see your answer. Nolchung, I see your answer as well. So the lowest common multiple between 5 and 25 is 25. Yeah, and lest we forget, we count in fives: 5, 10, 15, 20, 25. Count in 25s: 25, 50. But you can see, guys, that 25 is definitely the what? The lowest common multiple between who? Between 5 and 25 by inspection. Let's come here, 7 and 13. What is the highest common factor between 7 and 13? Highest common factor between 7 and 13. Highest common factor. Remember, guys, we first think, what are the factors of 7? What are the factors of 13? Then from there, we select the factor that is the highest, right, between 7 and 13. Be careful there, Gift Leandis. Be careful there, all right? Nolchung, I see your answer as well. What is the highest common factor between 7 and 13? Okay, so we need to first identify the factors of 7. Because this is a prime number, we know that the factors of 7 are going to be 1 and 7. Because 13 is a prime number, we know that the factors of 13 are going to be 1 and 13. So your highest common factor between 7 and 13 gives us a beautiful, amazing 1. Okay? Okay, sorry. Then what is the lowest common multiple between 7 and 13? What is the lowest common multiple between 7 and 13? Let's learn anything. Yeah, you better learn anything. What is the lowest common multiple between 7 and 13? Yes, what is the lowest common multiple between 7 and 13? We are here now. Lowest common multiple between 7 and 13. Lowest common multiple between 7 and 13. Never. It can never be 1. Never. Never. Okay, let's learn anything or someone that I actually I'm going to have to get rid of you, because I think you are you are someone who likes messing around. I think if I'm having my memory serving me well. Yeah, there we go. I think let's get rid of you. When Sokolisa, you are Sokolisa you. Okay, so lowest common multiple, I see Nolchung is saying 104. Is that a shared consensus? Z is saying 7 times 13, in other words, 91. Yes. The lowest common multiple, guys, between 7 and 13. Okay. Key 91. 91, 91, 91, 91. Yeah. Okay. Highest common factor between 1, 3, and 5 is 1. What is the lowest common multiple between 1, 3, and 5? Three numbers now. Lowest common multiple between 1, 3, and 5 is? Lowest common multiple between 1, 3, and 5 is? We've got 15 from Z, we've got 15 from Nolchungu. Oh no. I think you, nope. Nope. Who's G with the Nardos. Careful. Okay. Nardos. VRX. Be careful there. It's not, can't be 3. Lowest common multiple. Remember, multiples of 1, multiples of 3, multiples of 5. When you actually generate those individual multiples, you will get to a trio of values that basically are common, your first common values, you know. So if you run your multiples of 1, you run your multiples of 3, you run your multiples of 5, what you should get is you get to the first multiple that is common for all 3 numbers. It can't be 3. It definitely is what? Yes. You see now you are with the game, my dear. Yes. Now you are with the game. And obviously 1, you can count all the way to 15. So you can see that the lowest number that you arrive at as you run those multiples is 15. Okay, highest common factor of 2, 4, and 12. What is the highest common factor between 2, 4, and 12? Let's start with the highest common factor. 2, 4, and 12. The number that goes into 2, the highest number that goes into 2, but also goes into 4 and goes into 12 as well. What is that highest number that goes into? Okay, because factors are numbers that go into without leaving a remainder. Yes. Nolchungu, yes. Mpumzi, very good. And Nardos, very sweet. Yes. The highest number that fits into 2, 4, and 12 is 2. Lowest common multiple. What is the lowest number that is a multiple of 2, 4, and 12? Yes, very good, Nardos. Nardos is even explaining there in the comment section. Nice stuff. Now let's move on to the lowest common multiple between 2, 4, and 12. So out of the multiples of 2, 4, and 12, all right, which one is the common multiple of 2, 4, and 12, which is the lowest? So if you run your 2s, you run your 4s, you run your 12s, you generate your multiples of each number. Which is the lowest common number that you find between 2, 4, and 12 out of the multiples? Multiples, what is the lowest common multiple of 2, 4, and 12? That's what we are asking here, okay? Natasha, yes, Natasha, thank you so much, Natasha. I see you there. Nolchungu, I see you there, having commented initially. Mpumzi, I see you there as well. Yeah, be careful there, Nardos, ne? Be careful. Need to be very careful, guys. And we are doing all of this by inspection. In other words, they just want to see how sharp your mind is as far as your multiples. Because if you are someone that is coming from primary, okay, if you are coming from primary school, guys, remember the requirement when you finish grade 7 in primary school is that you should know your multiplications timetable. Okay, you should know your multiplications timetable from 1 to 12. You should know your times table off by heart. It should be something you know off by heart, you know. So hence when we talk about multiples, you should think of multiplication, all right? So the multiples of 2 is something you should know, because your 2 times table you know very well. The multiples of 4 you should know off by heart, because the multiplication of 4, the times table for 4 is something you should know. And then multiplication times table of 12 you should also know, because in grade 7 the requirement is that you should know your times table from 1 to 12 off by heart. So if I ask you for the LCM of 2, 4, and 12, right? In your head, the multiples should be running, and your head should be making connections that, okay, the lowest common multiple between 2, 4, and 12 is 12, you see? Yeah, but the thing is, if the mind has nothing of that information, then basically you are playing a guessing game. Okay, so those who are able to really use by inspection well are those that know their times table, and it is in their heart and mind. Others will have to really dig deep. Okay, let's move. Let's start here with the lowest common multiple. What's the lowest common multiple, guys? Now we are starting with the lowest common multiple, so be careful. What is the lowest common multiple between 15, 20, and 30? Lowest common multiple between 15, 20, and 30. Okay, I see Nolchungu, thank you. Z, I see you there as well. Lowest common multiple between 15, 20, and 30. Mpumzimbanzi, I see what you said as well. Lowest common multiples. Remember, multiple, okay? So the multiples of 15, you're counting in 15s, 15, 30, 45, 60, and so forth. 20, 40, 60, 30, 60. So I'm sure you guys can quickly see that the lowest common multiple is 60. What is the highest common factor? Now we are back at the factors. Highest common factor between 15 and 20? Highest common factor between 15, 20, and 30. Yeah, and guys, our agility to be able to find the highest common factor between numbers lays the foundation for our grade 9 and grade 10 work when we start dealing with factorization. You being unable to identify the highest common factor will lead to a poor approach in your factorization in grade 9 and in grade 10, and then that breakdown of poor being unable to identify highest common factor is going to lead to other problems. We will be able to foresee other problems in algebra, which will then cascade and affect your mathematics unfavorably. So that's why it's so important, man, to just know how to, this highest common factor thing might seem like such a, I don't know, by the way thing, but it's so important. It lays such a big foundation, So I would really encourage you guys to really like your times table, man. Yeah, the times table. Because your times table is a composition of factors, mas. When you say the 3 times 2, remember that you are basically saying that the 2 and the 3 that are being multiplied, they are of themselves factors of 6. 2 and 3 is a factor of 6. So that's why I'm saying you guys need to know your times table. So at the root is your times table, and from there springs forth the whole idea of factors and multiples. So please, man, please. So yes, you guys are correct. Your highest common factor between 15, 20, and 30 are 5. Why? Because if you run your factors of 15, you have 1, 15, 3, and 5. Okay? Does that make sense? Then 20. The factors of 20 1 and 20, 2 and 10, 4 and 5. Yabo? Then you have the factors of 30, 1 and 30, 3 and 15, 2 and 15, 3 and 10, 5 and 6. But then you can see that what's common there will be 5. You see, hence I'm saying you run your factors of 15, 1 and 15, 3 and 5. Those are your factors of 15. Factors of 20, 1 and 20, 2 and 10, 4 and 5. Factors of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. But you can see what's the highest factor that is common is 5. You see, it's 5. There's nothing greater than 5 that is common for all three numbers. So it's 5, guys. The highest common factor is 5. All right. Now imagine if you are factorizing in grade 9 and grade 10 and you don't know how to identify the highest common factor, or you don't identify the factor that is the highest, but you identify a factor that is common. That's still not good enough. You need to be able to specifically identify the highest common factor. Okay. Next, 120, 240, 360. What is the, let's start with the LCM. What's the lowest common multiple between 120, 240, and 360? Lowest common multiple, let's start there. Lowest common multiple, ne? Don't forget, I said lowest common multiple. So if you run your multiples of 120, run your multiples of 240, and run your multiples of 360, your lowest common multiple, is it 120? Can't be. 360? Kind of makes sense. But remember, if you count in 120s, you have 120, 240, then 360. If you count in 240s, it's 240, 480, right? Can't be 360. Okay. It also can't be it can't be 360 as well, right? We want our lowest common multiple. It can't be 360 as well. 360? No. Okay. Because remember, if you count in 240s, 240 is followed by 48. So it can't be 240 as well. I mean, it can't be 360. It can't be 240. It can't be 120. So what is the lowest common multiple? I repeat, what is the lowest common multiple between 120, 240, and 360? It's not 360. 360, it can't be. It is not. Okay. So I'm going to give you a bit more time to really thumb through it. Lowest common multiple between 120, 240, and 360. Lowest common multiple between 120, 240, and 360. What is the lowest common multiple? That is the question that is at hand. What is the lowest common multiple between 120, 240, and 360? And we were told, write down the LCM by inspection. Sure. Oh, there we go. There we go. Seems like Master Z was able to finally crack the code there. If you count in 120s, if you count in 120s, you do get to 720. 240, you do get to 720, and 360, you do get to 720. So yes, very good. 720, guys. 720. Z got it. Sis Z got it. Sis Z. Sis Z. It's 720, guys. 720 is the lowest common multiple. By inspection, it's 720. Highest common factor between 120, 240, and 360. I think someone did get it earlier on when they commented on both the LCM and the HCF. So the highest common factor between 120, yes, not true, that's the one. It's definitely 120. So you see, yeah. Okay. All right, now we move on to writing each number as a product of its prime factors, and then thereafter determining the LCM and the HCF of the numbers. All right, so let's first write each number as a product of its prime factors. Then we can determine the LCM and the HCF of the numbers. So we have quite a few that's coming up. All right, yeah, quite a few coming up. This page, that page. Yeah, we have a few coming up. Then that will mean we'll have wrapped up this LCM and HCF and factors situation. Put it to bed. Okay. So guys, let's let the method everything first. Let's let a method everything so that we can find the product of prime factors. Even though we know we can use our calculator, let's just let's get our minds sharp in the game. Smallest prime number that goes into 12 is, so that I can get those down. Smallest prime number that goes into 12 is okay, it's 2. How many times does 2 go into 12? Very good, guys. It is definitely. Okay, how many times does 2 go into 12? Yes, not true. 6 times Z, definitely. Smallest prime number, yes, Smallest prime number that goes into 6. Smallest prime number, yes, Natasha, yes, Z. Smallest prime number that goes into 6. Yes. The smallest prime that goes into 6 is definitely 2. Yes, Z, yes, Natasha. Yes, not true, yes, Mpums. How many times does 2 go into 6? Yes, indeed, 3 times. Smallest prime number that goes into 3. Smallest prime number that goes into 3. Yes, it is 3, guys. Very good. And how many times does 3 go into 3? Very good ones. Then we know that's where we stop, right? So 12 is equal to, how many 2's do we have? 2 of them. How many 3's? 1. Now let's go on and do it to 20 as well. Smallest prime number that goes into 20. So this is our product of prime factors for 12. Smallest prime that goes into 20. Yes, see, it's 2. Definitely. Smallest prime that goes into 20 is 2. How many times does 2 go into 20? How many times them 2 go into 20? Yes, see, 10. 10 is a fan. Yes, Yes, Natasha, December, Pumzi, very good. Smallest prime that goes into 10. Smallest prime that goes into 10. Very good. Pumzi, it's 2. How many times does 2 go into 10? December, very good. Thank you. How many times does 2 go into 10? Sweet, Mbumzi, Z, yes. 2 goes into 10 5 times. Smallest prime number that goes into 5. Yes, smallest prime that goes into 5 is 5. How many times does 5 go into 5? Again. 5 goes to 5 once. Very good. So that means that's where we end. So our 20, how many 2's do we have? We have 2 of them. And then the 5 is just on its own. Now, remember they said write each as a product of its prime factors. So we've done that. 12 is 2 squared times 3. And we know that 2 squared times 3 is really 12. 20 is 2 squared times 4. 2 squared is 4. 4 times 5 is 20. So these are really, truly your prime factors. Now they want us to determine the what? The LCM. And then afterwards, the HCF. So let's do first concept first. LCM. When we are identifying the LCM, okay, what can we write here as a product so that our LCM is accounted for? All right. Do we still remember? From this product of prime factors, who are we going to write as our product of those prime factors? Who are we choosing? Okay. Z is saying all the available factors. All the available factors. Guys, is Z substantiating or supporting? Or so in other words, what then would be the answer for our, okay, so what we can see firstly is that, okay, firstly we can see, hey, we have common bases here, and obviously for the lowest common multiple we go for the common base with the highest exponent. If anything is common, then we go for the common base with the highest exponent, right? So here, 2 squared, 2 squared, since it's common, it's the same, we are going to take 2 squared, harvest him once. We are done with base 2. And then base 3 is a leftover. We are taking him as well. Base 5 is also another leftover. It is different from base 3, so we are also taking him. So the product of the common base with the highest exponents together with our leftover bases will basically make up our LCM. So as said, 2 squared is 4 times 3 times 5. That gives us a beautiful number, 60. So we say 60 is the lowest common multiple. Let me repeat this again. If we have common bases, we choose the common base with the highest exponent. But for LCM, we also consider what I call our leftover bases. If those bases that are left over do repeat, then we basically choose the base with the highest exponent. But if those leftovers are just single on their own, we take them because most they are single. So L for lowest common factor means lowest common multiple means leftover. So we take the leftovers, the 3 and the 5, we take it as well to be a product of 2 squared, which is the common base with the highest exponent, and we get our answer. The LCM is 60. What about the highest common factor? Who are we selecting? What are we doing here with the highest common factor in our selection? Highest common factor. There's the product of prime factors for 12 and for 20. So what do we do this time round for highest common factor? Okay, so for highest common factor, we are very strict. It's only the common. We have to choose. We choose common base here. Here we are strict with common base, but we choose the common base with the lowest exponent. Only. If you are not common, you are not chosen. If you are not common, you cannot be chosen. So for instance, base 2 is common. So we can choose from base 2. Base 3 and base 5 are leftovers. We don't even look in their direction. Why? Because they are not a common base. So here we are strict. Here we choose common base with lowest exponent only. No leftovers. Okay. So if we look at base 2, base 2 is common. So we are going to choose there the base with the lowest exponent. But the exponents are the same. So we choose once, 2 squared. So that means our highest common factor is 2 squared, which is 4. Are we together, guys? Is the explanation clear? Lowest common multiple. If there are things that are common, you choose the common base with the highest exponent. But we also include the leftovers. Leftovers are basically the ones that are not as common. For highest common factor, you have to choose from the common bases there. There's nothing that has to do with leftovers there. Leftovers we don't even touch, you see. Yeah. Okay. Leftovers we don't even touch. You see, common base with the lowest exponent is what we are going for with highest common factor. And we do one selection from what is common, but the base with the highest exponent, with the lowest exponent, and then we don't even touch leftovers there. All right, so we are done there. LCM is 60, the HCF is 4, between 12 and 20. Let's go on. Let's come and do this one. 24 and 36. Okay, so let's start it out with our ladder. Let's ladderize and get the product of prime factors. So 24 on this side, I'm gonna ask you, what is the smallest prime number that goes into 24? Yes, see, thank you. Natasha, thank you. Litemba, thank you. Thank you. Lowest prime number is 2. How many times does 2 go into 24? Thank you, Petro. How many times does 2 go into 24, guys? You identified the right prime number. Very good. How many times does 2 go into 24? Yes, C, 12. Yes, Nhlamulo. Yes, Petro. Yes. Yes, Litemba. 12. Smallest prime that goes into 12? Smallest one. Smallest prime number that goes into 12. Remember, a prime number is a number that has 2 factors, one and itself. So basically, numbers like 2, 3, 5, 7, these are prime numbers. But Tina, we want the smallest. It is 2. Very good. 2 goes into 12. How many times, guys? How many times does 2 go into 12? 2 goes into 12. How many times? Yes, Petro. Yes, Z. Yes, Nhlamulo. It goes into 12 6 times. Smallest prime number that goes into 6. Smallest prime number that goes into 6. Smallest prime number now that goes into 6. Yes, Z. It is 2. Petro. Yes, Natasha. Nhlamulo, Litemba. You guys are amazing. How many times does 2 go into 6? G-Vax. Smallest prime number that goes into 2 is into 6 is 2. How many times? Very good, guys. Nhlamulo, Petro. 3 times. Beautiful. Smallest prime number that goes into 3 now. Smallest prime number that goes into 3. Smallest prime number that goes into 3. Yes, Z. Yes, Petro. Smallest prime number that goes into 3 is 3. How many times does 3 go into 3? Litemba. How many times in Nhlamulo? How many times GX? How many times does 3 go into 3? Yes, Yaya. Yes. Yes, Litemba. Yes, Natasha. No, Yaya. Yes, Yaya. Only later on. Yes. Petro. Yes. Nhlamulo. Yes. Once. Okay. So our product of prime factors will write very soon. Let's go to 36 now. Let's take care of 36. Smallest prime number that goes into 36? Smallest prime number that goes into 36? Yes, Z. It's 2. How many times does 2 go into 36? Yes, the 18. Tlamulo, 18. G-Wax, yes, 18. Petro, be careful, it's not 16 times. 2 doesn't go to 36 16 times. Remember, in your calculator, you can say 36 divided by 2. Then it will help you. Very good. Now, 18. Redeeming yourself there, Petro. And Natasha, thank you. Smallest prime number that goes into 18. Smallest prime number that goes into 18. Yes, Z, it's 2. And Tlamulo, it's 2. G, yes. Natasha, yeah, yes. 2. How many times does 2 go into 18? Yes, Z. Tlamulo, yes. Petro, yes. G, yes. Natasha, amazing. Yes, 9 times. Smallest prime number that goes into 9? Smallest prime number that goes into 9? Yes, Z, 3. Petro, yes, 3. G-Vax, yes. Nhlamulo, yes. It's 3, guys. How many times does 3 go into 9? Yes, Z, 3 times. Petro, yes. G-Vax, yes. Natasha, yes. 3 goes into 9 3 times. Smallest prime number that goes into 3 now? Sakile Mahlangu, thank you, yes. Yes. Smallest prime number that goes into 3 is 3. How many times does 3 go into 3? How many times does 3 go into 3? Yes, Z, thank you. Petro, yes. G, yes. Natasha, amazing. Once. So therefore, we are complete. We stop most when we get to 1. Now 24 can be written as, how many 2's do we have here? We have 3 of the 2's. How many 3's do you have? Only 1. Does it make sense? 2 to the power 3 is 8. 8 times 3 is really 24, so this makes sense. Then we write down 36. How many 2's do we have for 36? There's 2 of them. How many 3's do we have? There's 2 of them. Any leftovers? No leftovers. So that means for our lowest common multiple, we are not going to be worrying about leftovers. We only have common base all the way. So now LCM, common base, if there are, we take the common base with the highest exponent. The product of the common bases with the highest exponent will be my LCM. So 2 cubed and 2 squared, who are we choosing? Who are we taking? Who's getting taken? Who's getting taken? Common base with the highest exponent. 2 cubed is being taken. Let's take him. He's taken. Multiplied by base 3 is also common. So who are we taking? Base with the highest exponent. Who are we taking? Who's getting taken? Let's take him. Okay, 3 squared is getting taken. Base with the highest exponent, because that's what we take for our LCM. 3 squared. Then we do the maths. 2 cubed is 8. 3 squared is 9. 8 times 9 is 72. That is the LCM of 24 and 36. It is 72. Even by inspection, you know that the LCM of 24 and 36 is 72. Even by inspection. Now let's go and take our HCF. What is highest common factor, guys? Highest common factor, we choose the common base. Okay, it is only the common base that we take. Only choose the common base, but with the what exponent? With the lowest exponent, guys. We choose the common base with the lowest exponent for HCF. Okay, common base with the lowest exponent. Z, I don't know what you're answering for, my dear. 8 times 4 times 3 times 9. Aki zimdase. Near. All right, please, guys, We don't choose all of the bases for LCM. No, 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 no. Okay. If the bases are common, Zine, we choose the common base with the highest exponent for our LCM. But remember, LCM takes leftovers, and by leftovers we mean other bases, if they are there and they are not common for all the numerical values. Okay, please. And even if we have other bases, we still look, okay, for the base with the highest exponent. This is very important, this thing, right? Yeah. Now HCF hides common base. We only choose common base, but with the what? With the lowest exponent. So here we see it's common. Who are we choosing? Who is going to get taken? Who has the lowest exponent between 2 cubed and 2 squared? So it means we are going to take 2 squared, but we are going to multiply it with who? Base 3 is also common, but who are we going to choose? The one with the what? The lowest exponent. Who's that? It's 3. So that means 4 times 3 is 12. So that is our HCF. Guys, I hope this is not confusing. Okay. Yeah. Right. All right. So for LCM, please listen to me when I say, for LCM, we can choose from the common base. All right. But we also choose from the leftovers that are not the common base. Okay. This is very important. Okay. So we initially choose from the common base, but we can also choose from the bases that are not common, because those are what we refer to as the leftovers. Okay. Yeah. So yeah, I hope as we do more, you'll see, you know, the what you might call the flow. Okay. Yeah. Because guys, the thing is, here in the problem, they are saying write each number as a product of its prime factors. That's what they said. And determine the LCM and HCF of the number. So we have to first write the numbers as a product of prime factors, and then from there we derive the LCM and the HCF. So this method, unfortunately, is what we have to stick to. All right. Yeah, because we are given the instruction to do so. There are obviously other methods we can use to find LCM and HCF, but it's just that the instruction of the question is saying this. That's why we are taking this route that we are taking, right? So 25, 35. Let's get kicking again. 25 and 35. All right, 25 and 35, let's find the prime numbers that go into 25 with the smallest. Let's start there. Smallest prime number goes to 25. Okay, so smallest prime number that goes to 25 is definitely 5. How many times does 5 go into 25? Okay, very good, Jamulo, very good. Natasha, Chappies, power, welcome. Natasha, yes. 5 goes into 25 5 times. Smallest prime number that goes into 5? Yeah, you could swear we are being gun pointed here to like say the number 5, whether we like it or not, again and again. Hey, so 5 goes into 5. How many times does 5 go into 5? That is the smallest prime number indeed. How many times does 5 go into 5? Definitely Z. Thank you so much. Beautiful. Yes, Natasha. My poor nickname has been through a lot. Chappies, power, come. No, don't worry. It will still go through a lot, my guy. Yeah, we are still going to go through a lot. I guess you're going to have to develop a very thick skin in your life so that you can survive what your name has to go through. Okay, 35. Smallest prime number that goes into 35. We're done with the 25. Let's go to 35 now. Smallest prime number that goes into 35. Very good, guys. It's 5. Beautiful, beautiful. How many times does 5 go into 35? Very good, Z. Very good, Chappie Z. 5 goes into 35 for 7 times. Smallest prime number goes into 7. Smallest prime number goes into 7. Chappie 7. Jamulo 7. Z 7. Natasha 7. Yes. How many times does 7 go into 7? We want beast mode, beast mode, beast mode, beast mode. Yes, 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 Chappies, yes, Z and Natasha. 7 goes to 7 once. Okay, we are done. So now let's write down the product of prime factors. 25 is 5 squared, whereas 35 is 5 times 7. So let's start with the LCM, the most famous, because that's the one that requires us to even consider leftovers. So LCM, if things are common, if we are chappies, we are writing each number as a product of its prime factors first. So that's why we are using the ladder method to actually accomplish that. Then after that, we are determining the LCM and the HCF of the numbers. That's what we are doing. We are answering this main question for different numbers. Okay. Right, so now, since we are in LCM mode, we know that for LCM, if there are things that are common, like for instance, base 5 is common for both 25 and 35, then we know that we choose the common base with the highest exponent, okay? Fortunately or unfortunately, only base 5 is common, so therefore we go ahead and we choose who between 5 squared and 5. Common base with the highest exponent. Who are we choosing? Who do we choose between base 5 squared and base 5? Exactly, thank you, Pedro. We choose 5 squared. We then multiply it with what? Now, we are done with base 5. We are no longer going to even take a look at base 5 anymore because we've made our selection. Unfortunately, once you make a choice that you want to be with her for the rest of your life, you can't make a secondary choice while still in that devoted marriage. No, 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 no. You stick to your choice. You choose your love and you love your choice. 7 is a leftover. 7 is a leftover, my guys. And remember, I said for LCM, we also take the leftover. Okay? And because it is the only one, we take him. Therefore, the LCM is going to be 25 times 7, which is what, my beautiful people? I know you know the maths there. Please tell me what the answer is. What's 25 times 7? Tell me. Tell me, my beautiful people. Tell me. Tell me. Me trusting my people will tell me. Hey, Natasha. Hey, Natasha. Yeah, thank you so much. Ntlamulo, thank you. Confirmation 175. That's the LCM. We want the HCF as well. Okay? The HCF, what did we say? We only choose from the common base, guys. We leftovers, we don't even care. You are still calculating, chappies. I'm sorry, man. Don't worry. Don't worry. As long as you know what you are doing, that's all that matters. The glory of answering the question and commenting is reserved for those that are quick. Okay, chappies, Bible, come. Did you know? Did you know? Chappies, did you know? Did you know that 0 is the smallest even number? Okay. Okay, common base. So here for HCF, common base with the lowest exponent. We only choose from the common bases. Leftovers, we don't even go towards, right? Choose the common base, and it has to be that common base is common for every number. It can't be common for some of it. Has to be common for all. Common base for all. This is very key. Yeah, when you go to HCF, you choose the common base for all. that has the lowest exponent. So who is the common base for all? It is only 5. Which one has the lowest exponent? There's only one, and that is 5. And that is him. That is the answer. That's the only thing. There's nothing more we can do. Okay? Leftovers, we don't even go and look at all. All right? Let's do again the previous example one of the same method. This one. You mean this problem? Z. You mean this one? Number one. You mean this one? Okay, I don't think I want to be going through the ladder method most. The ladder method is pretty straightforward, you know. Are we all good with 12 being 2 squared times 3? And then 20 being 2 squared times 5? Are we good with that? Because 4 times 5 is 20, it makes sense. 4 times 3 is 12, it makes sense. Then LCM, what did we say? Okay, common base with the highest exponent, right? And remember, if the common base is there, then obviously we're going to choose the common base with the what? With the highest exponent, if the common base is there, all right? So for 2 squared and 2 squared, we are going to choose 2 squared once. We are not going to choose 2 squared, both of them. No, what is common is 2 squared. So let's choose 2 squared. We select 2 squared, we are done. Then 3 is alone, it's a leftover. 5 is alone, it's a leftover. It gets included in our product of the multiples that we basically have. So 2 squared, chose once. 3, he left over and 2. 5, he left over and 2. 2 squared times 3 times 5 is basically the LCM. Then HCF, common base for everyone most. The only common base for everyone is 2. But then obviously the one with the lowest exponent, we just choose 2 squared once. That's basically our HCF. Give 4 and 2. Right? So I don't know if you are still Z. I don't know if like the example, is there something that basically you are not understanding? Okay, are we good? All right. Let's move on, because there's more to be moved on to. Let's go again, guys. Are you ready? Are my smallest prime number people ready? Let's ready, steady, go. 60. Smallest prime number goes into 60. Ah, look at you. Chappies is quick in the hands. They're like quick to type. Yes, smallest prime. Yo, Chappies is getting ahead of the game even. Smallest prime that goes into 60 is 2. How many times does 2 go into 60? Chappies is like answering for the next. Oh my goodness, why is this guy, why is this person cracking me up? My goodness. 2 goes into 60 how many times? Yeah, so 2 is the smallest prime number. 2 goes into 60 how many times? 30. Smallest prime number that goes into 30? He's bubbling with the calculation. I'm telling you, he is indeed. Smallest prime number that goes into 30? Yes, guys. Chap is very correct. Natasha, very correct. It's 2. How many times does 2 go into 30? It's a competition for champions. Oh my goodness. 2 goes in. Chavis is competitive. Yo, I just. Yo, I... 2 goes into 30 how many times? Yo, 2 goes into 30, 15 times. How many times? What is the smallest prime number that goes into 15? Okay, it's 3. Very good, guys. 3. Yes, Chappie, it's 3. Petro, it's 3. How many times does 3 go into 15? Yes, Chappie, it's 5 times. Petro, 5 times. Definitely, guys, 5 times. Smallest prime number that goes into 5? Yes, Chappie, it's 5, definitely. And how many times does 5 go into 5? It's 5 again, indeed. How many times does 5 go into 5? Then 1. definitely 1. Making my morning making my day, by the way, the Chappie. Smallest prime number that goes into 80. Turn our attention to the number 80 now. Smallest prime that goes into 80? Yes, it's 2. How many times does 2 go into 80? Petro, thank you so much. Yes, chappies. 2 goes into 80 40 times. Smallest prime that goes into 40? Yes, chappies, it's 2. Petro, yes, it's 2. How many times does 2 go into 40? Yo, look at that. 2 goes into 40 indeed. 20 beautiful times. Very good, Petro. Thank you so much, guys. I love the swiftness in which people are interacting there. Smallest prime number that goes into 20. Yes, Natasha. Yes, Chappies. Yes, Petro. It's 2. And how many times does 2 go into 20? Definitely 10 times, guys. 10 times. Smallest prime number goes into 10. We're going down. Smallest prime number that goes into 20. Yes, it's 2. How many times does 2 go into 20? Yes, Chappies. Yes, Natasha. Definitely 2 goes into 10 5 times. Smallest prime number that goes into 5? Smallest prime number that goes into 5? Yes, Chappies. Definitely 5. How many times does 5 go into 5? 1 time. 1 time. 2 times. 1 time. Okay, definitely once. Right. So now our product of prime factors in exponential form, 60 is equal to, how many 2's do we have? There's 2 of them. How many 3's? 1. How many 5's? 1. Then 80. How many 2's do we have? There are 4 2's. How many 5's? Just 1. Okay, no 3. So let's start there with Mr. LCM. From there, we know all we want there is the base with the highest exponent. Okay, if it's common, and of course from our common base, we go for the base with the highest exponent. So 2 and 2, we get 2 to the power 4 as the base with the highest exponent. Yes, Petro. 5 and 5, 5 and 5, they are common and common with their exponents as well. But we choose 1, guys. We choose 1. Okay? Then base 3 is a leftover. It's on its own. So base 3 is included in our product because it's a leftover. All right? Single separate base from all the other bases. It's a leftover, so we include it. Then we multiply 16 times 5 times 3, which is 15. 16 times 15, guys, or 16 times 5 times 3 gives us a beautiful answer of, I'll wait for you guys to give me the beautiful answer on your own, because let's see who gets the glory. Who gets the glory? Who gets the glory of the answer? Natasha there was quick on the calculator. 240 is the LCM, guys. Then HCF. Remember with this one, we only look at common bases for all the numbers, not leftovers. We don't even care about leftovers. Okay, common base alone with the highest, with the lowest, okay? Because highest common factor means we choose the common base with the lowest exponent. Leftovers we don't even look at. So base 2 is common for both numbers, for all, which is great. Base 5 is common for all. So we choose from base 2, we choose from base 5, but then we go for the common base with the lowest. So yes, Pedro, for base 2, we are going to choose 2 squared, which is going to be multiplied with what? Base 5, the same for both, we choose 1. So that means the 4 times 5, which is equal to 20. Okay. All right. Easy, ne? Easy, Baba. Easy, Baba. Let's see if we have 3 numbers. What happens? Want to find LCM, HCF for 3 numbers. So let's pull the deal. 6, 9, 12. 6, 9, 12. Okay. Cruise. Smallest prime number? Yes, is 2. How many times does 2 go into 6? Yeah, now I'm just going to not really spend too much time. Yes, 3, guys. Smallest prime number goes into 3. 3 again. How many times does it go? We stop. Move on to the next number. Smallest prime number goes into 9. Yes. 3. How many times does 3 go into 9? Yes, Natasha. 3 times. Very good. Smallest prime number that goes into 3. Yes, Natasha. Yes, chappies, it's 3. How many times does 3 go into 3? Very good, 1 time. Smallest prime number that goes into 12. We are moving. Smallest prime number that goes into 12. It is 2. How many times does 2 go into 12? 6. Very good. Smallest prime number that goes into 6. Hayi Pedro. Ngizawushapa wena ngwane. Ngawushapa 4 for the y. Ngizawushapa wena. Smallest prime number that goes into 6 is 2. How many times does 2 go into 6? I'm not expecting you guys to be making silly mistakes here in the letter. Come on. Unacceptable stuff. 2 goes into 6 how many times? 3 times. Smallest prime number that goes into 3? Very good. 3. How many times does 3 go into 3? Of course, once. Now let's write all them numbers. 2, 9 is 3 squared, 12 is 2 squared times 3, whereas 6 is 2 times 3. Okay, now let's start with the LCM as always. So the first thing we say, we look for who's common for all 3, because whoever is common for all 3, we know we just need to select the base that has the highest exponent. So 3 is common for all 3. So we are going to say 3 to the power what? 3 to the power, because we are common for all. 3 to the power 2, right? The base with the highest exponent. Then base 2 is a leftover because it's common only for the 2 numbers, not for all 3. So it's a leftover, but even amongst the leftovers, we need to choose. If it's common just for the 2, it's a leftover, but then we choose the common base still there that has the highest exponent. So 2 squared and 2, who are we going to choose? It's common for 2, not common for all. Exactly, we are going to multiply it by 2 squared. Thank you very much. And that's it. That's it. So 3 squared is 9 times 4. What is 9 times 4, my beautiful people? Let me allow someone to get the glory. What's 9 times 4? Who here knows the timetable, guys? 9 times 4. Yes, chappies. Hi, Shibe. Be careful there. 54. Ay. Kitlaw shapa wena. Kitlaw shapa. Kitlaw shapa. Please, guys. The last place where we need to be making errors is when we are multiplying numbers. At this stage, that shouldn't be happening, okay? Especially because we also have a calculator to actually punch and verify answers, okay? Chino sto there, shapa, huh? Okay, highest common factor. Okay, remember with the highest common factor, we only look at the common basis for all. When you're chappies, that's very good. Very good. Yeah, that means your mind is sharp. Guys, remember, the more you use your mind to do things, then the sharper your mind is. But the less you use your mind and you divert even simple tasks like multiplying things, you divert them to the calculator, you are going to find yourself becoming more lazier and lazier, and your mind becomes more passive and passive. So it's important to sharpen your mind, by constantly revisiting it to basically do simple arithmetic calculations and so forth. Okay, so highest common factor, we're only looking at common basis for all. Our selection is just no leftovers. So it has to be common for all. So the interesting thing here is that we are only going to be making a selection here for base 3. Only for base 3. Okay. Zip. There's people who are just I guess getting crazy outside here. Zip. Okay, base 3, guys, is common for all. Our selection for highest common factor is only made from the common base for all. Not common for some. Common for all. So the common base for all, which has the lowest exponent. So we have base 3, 3 squared, and 3. So we are going to select 3. That is our highest common factor. We can't choose from base 2. Okay, because it's only common for 2 and it is a leftover. If you are not common for all the numbers, you are a leftover. But if you are common for all, then we can select from you. Highest common factor only selects from the common basis for all that have the lowest exponents. Okay, right, I hope that makes sense. So for HCF, we are choosing from the common base 3, which is common for all 3 numbers. That 3 is common for 6, it's common for 9, it's common for 12. So we choose the common base for all that has the lowest exponent. That's how we select for highest common factor. So 3 squared, and 3, obviously 3 has the lowest exponent, 3 to the power 1. So we just select 3 once and we write 3 as the highest common factor. It's as straightforward as that. Yes, chappies. But remember, chappies, as I said, that common base needs to be common for all your numbers. If it's not common for all your numbers, we dare not look in that direction and make a selection. For instance, I said base 2 here is not common for all. We don't select from base 2 for a highest common factor because base 2 is common for just 2 numbers. It is regarded as a leftover, all right? So we don't choose from there. But with the lowest common multiple, what did we do? We looked at common base for all we made a selection of the base with the highest exponent. Then we looked at base 2. We saw, oh, it's a leftover. It's common only for two numbers. But still there, we choose the base with the highest exponent. Okay? We choose the base with the highest exponent. Guys, as long as you just get the fact that for LCM, it's the base with the highest exponent. So as I said, here we first look 3. 3 is common for all. Since 3 is common for all, we choose the base with the highest exponent. So that's why we chose base 3 to the power 2. Then base 2 is not common for all. It is regarded in my language as a leftover. But as it is a leftover, it is common for these two numbers, 6 and 12. Therefore, our leftover, which is base 2, we still are going to, because base 2 is common for the two number, we are still going to choose the common base with the highest exponent. So we choose 2 squared alone, and then we multiply, we get our answer. Okay. Yes, for LCM, if there are other uncommon factors to the ones that we have there, all right, if those numbers are there, we include them because they alone are actually the bases that have the highest exponent as that number. All right. So guys, for instance here, 3 is uncommon, but it is alone as the base with the highest exponent as base 3. 5 is alone, but it is alone as the base, the only base with the highest exponent. So that's why we are actually including it here. All right. Yeah, it is alone as a leftover as the base with the highest exponent. So we include it. We include the 3. But for the common ones, obviously, we are just going to select the base with the highest exponent. So we are just pumping in the bases here that have the what? The highest exponent. That's what we are pumping in here for LCM. Yeah, we are selecting from everything. Okay. I was going to explain, but I don't know how to explain. It's fine. Hopefully, we are finding the best explanation through the continuous examples that we are doing, because I need you guys to get it. All right. I need you guys to get it, even so much so that you will be able to explain it in your own way that will actually be understandable to you, you know. Yeah. So hopefully we understand why though here we got getting the answers the way that we are getting them. Yeah. Yeah. Let's move on, guys. 12, 18, 24. I know we are moving swiftly, guys. We are moving swiftly because I don't expect people to be giving us problems with letter method. Now, guys, check this out. Smallest prime number, 2. How many times? 6. Smallest prime number, 2. How many times? Yes, 3. Smallest prime number? 3. How many times? Yes. Okay, now let's go to 18. Smallest prime number? 2. How many times? 9. Very good. Smallest prime number? Yes, 3. How many times? Very good. 3. Smallest prime number? Yes, 3. Very good. How many times? Does 3 go into 3? Very good ones. 24, smallest prime number? Chappie is very good. Chichi, very good. Petro, very good. 2. How many times? Chappie's is so fast. It's crazy. Yes, Chappie's hundreds. Chichi, Petro, Chappie's, yes, 12. Smallest prime number? Yes, 2 is the smallest prime number. How many times? Very good, 6 times. Smallest prime number? Two, very good. How many times? Very good, 3. Smallest prime number? Very good. And how many times? Once and for all, how many times? Very good. So that's 12, 18, and 24. So if you write down 12, how many 2's do we have? We have 2 of them and 1 3. 18, how many 2's? We have 1. How many 3's? 2 of them. 24, how many 2's? We have 3 of them. How many 3's? 1. So let's just check and verify if it makes sense. 4 times 3 is 12, 2 times 9 is 18, and then 8 times 3 is 24. So it makes sense what we have here. Let's start with the LCM. Lowest common multiple. So what we are going to select here, what we first can see is that 2 is common for all, 3 is common for all. So we are not even dealing with any leftovers, which is great. So the question then is, which is the common base with the highest exponent for our base 2? Okay. And then which is the common base for our base 3 that has the highest exponent? Because the product of that should give us the LCM. So 2 what? 2 cubed is the highest exponent base. For base 3, it is 3 squared. So 2 cubed is 8 times what? What's 3 squared? It's 9. And then 8 times 9, guys, simply put, gives us 72. That is our lowest common multiple. Okay. HCF, as we said with this one, we just common base with the lowest exponent. Okay, it has to be common for all. We are common for all bases, which is great. Base 2, which one has the lowest exponent? Okay, definitely. Then base 3 is common for all as well. Which one has the lowest exponent? So you multiply those two and you get the answer. So your answer for the HCF. Okay, so the base with the lowest exponent is base 2. Multiply the base with the lowest exponent here is base 3 to the power 1. So 2 times 3, as we can see here, is 6. That is our highest common factor for this particular problem. There we have it. HCF and LCM in the bag. Okay. Okay. Guys, I'm not going to waste any time now and deal with the ladder method. I just want to say, you do know that you can grab your calculator without having to use the ladder method. And you can do the following. Grade 9s, this is something you can do. You can simply press 36 is equal to shift fact. HCF ndalo means highest common factor. Okay, highest common factor. So if you grab your calculator and you say 36 is equal to, and then you press shift, then you press fact. this is what happens. That ladder method that you are using can simply be gotten. You can get your product of prime factors by using the calculator. Let me just repeat that. What did I do? 36 is the number. So I'm going to say 36 is equal to, then I press shift, then I press fact. There it is. Okay. So 36 is equal to 2 squared times 3 squared. Let's go to 54. Do the same thing. 54 is equal to shift, then fact. Okay, there we have it. That's 2 times 3 cubed. Then lastly, 72 is equal to highest common factor, not fraction. 72 is equal to shift, then fact. Okay. Then there you have it. We have 2 cubed times 3 squared. Okay. So I'm just sharing this with you, okay, because as I said, if you are in grade 9, then basically you can use you know, this method of writing the number, pressing equal, pressing shift, and then pressing fact to get your product of prime factors, which basically will then, yeah. But of course, the ladder method is there for those that basically, if like use of your scientific calculator, you don't have it, then basically you can go ahead and, you know, ladder method it. But grade 9s, guys, really and truly, you guys are in the position of just simply, because in grade 8 we hammer in the ladder method, but in grade 9 you can actually go ahead without basically doing the ladder method. You can just simply use your calculator and write down the product of prime factors. Then from there, HCF and LCM, because in a way using that ladder method will take time. Okay, it will take time, you know, take time. Okay, yeah, Petro, you don't have a calculator. Yeah, and I would recommend, guys, if you can get the Casio calculator, get it. If you can get the latest version of the Casio calculator, there is the infamous white Casio calculator. It does a whole lot more than just that calculator. That calculator is like AI, you know, yeah. So yeah, make sure you get that get the Casio calculator so that you can be able to work these things out nicely. Right. So if we then go ahead and write down the LCM, we would use the ladder method. Okay, I'm gonna go back to the ladder method with the next problem, but I just wanted to share this with, you know, just the grade 9s that are here as well. So 2 squared times 3 squared, okay, that makes sense. 4 times 9 is 36. Okay. Yeah, Petro, it's expensive, that calculate. 54, 2 times 3 cubed, you know, 50, that's 27 times 2, which is 54, makes sense. Then 8 times 9, which is 72, so that makes sense too. So LCM, common base with the highest exponent. Obviously, this is common for all. We have no leftovers, which is great. So therefore, we can just say common base with the highest exponent. 2 cubed, 2 squared, which one? 2 cubed. And then 3 squared, 3 cubed, and 3 squared. We go for the base with the highest exponent. So that's 3 cubed. So it's 8 times 27. And that 8 times 27, that will give us a beautiful answer of 216. So that is the LCM, the lowest common multiple between 36, 54, and 72. HCF, we go for the common base, obviously for all, common base with the lowest exponent. So when you're going for when you're choosing highest common factor, you go for the one with the lowest exponent. High exponent, go for the low exponent. highest common factor, you are going for the lowest. When you're going for the opposite, okay. Yeah, so base with the lowest, that's 2. For 3, base with the lowest exponent, that's obviously 3, not 3 cubed, but 3 squared. Okay, and remember, we multiply, we don't divide. Okay, be careful making silly errors, guys. So it's 2 times 9, which is 18. So 18 is the highest number that basically goes into 36, 54, and the 72. It's the keyboard, not me. Jabbies. Okay. Let's go with this one, 63. Do you want to revert back? Do you guys want to revert back to doing the ladder method? Seems like people like Chappies are becoming very bored in the life if we don't do this ladder method stuff. Seems like there is a a dopamine rush that some are getting with being able to get the right responses. Okay, the smallest prime number that goes into 63, guys. Smallest. Okay. All right. Consensus is shared that the smallest prime number that goes into 63 is 3. Question is, how many times does 3 go into 63? Very good, 21 times. Smallest prime number that goes into 21? Yes, it's 3. How many times does 3 go into 21? Very good, 7 times. Smallest prime number that goes into 7? Yes, Petro, very good. Smallest prime number that goes into 7? Yes, it's 7. How many times does 7 go into 7? 1 time. Okay, let's go now to 105. Smallest prime number that goes into 105. Smallest prime number that goes into 105. Yes, Z, it's true. It is 3. Smallest prime number that goes into 105 is 3. How many times does 3 go into 105? Definitely Z, it's 35 times. Beautiful, 35 times. How smallest prime that goes into 35? It's 5. How many times does 5 go into 35? Z, very good, 7 times. Smallest prime that goes into 7? It is 7. How many times does 7 go into 7? Once. Smallest prime that goes into 147. Smallest prime that goes into 147. Yes, it's 3. How many times does 3 go into 147? So you say 147 divided by 3. I'm guessing even for people that don't know, play around with if you have your calculator, like I said, 105 divided by 3, you check, do you get a natural number? You should see. If you get a natural number, then bam, that's it. It is a number that goes into 105. 3 goes into 147 how many times? What's 147 divided by 3? It is 49, not 29. 49. Okay. Smallest prime number that goes into 49? No problem, Z. No problem. Typos definitely do happen. Smallest prime number, guys, that goes into 49 is not 3, it's 7. How many times does 7 go into 49? Okay, so this is where the calculator really will be handy if you have it. 7 goes to 49 7 times. How many times smallest prime number goes into 7? So that's why I'm saying my grade 9s shouldn't be crawling here. Yeah, when now you grade 9 should just be grabbing 147 is equal to shift fact, bam, you get your answer. Okay, 7 times. How many times does 7 go into 7? It's the smallest prime is 7. How many times does 7 go into 7? Oh dear, yes, once. Now that we have this, we write down 63. There's 2 3s and 1 7. 105 is 3 times 5 times 7, and then 147 is 3 times the 7 squared. So let's start with the LCM. Remember, LCM, common base with the highest exponent. So 3 is common for all. We are going to go for the base with the highest exponent. 5 is a leftover, so we are going to multiply by 5 because 5 is the only one. It is the only one with the highest exponent as base 5. 7, common for all. We go for the base with the highest exponent. That's 7 squared. So you can see the maths, how it comes together there. There's no 2, Z. Oh, there's 3. Oh, sorry, 3 squared. Sorry, I thought you were saying 2. Makes sense. Just that I didn't see that there was a cap there. All right, so that means 9 times 5 times 49, which gives you Caden. Can we verify Caden's answer? Is that 2,205 indeed, guys? Is Caden really Cadening it up? Confirmed? 2,205. Caden. HCF, highest common factor. Right? Highest common factor, we just look for common base for all, which has the lowest exponent. 3 is common for all, we are going to choose. 5 is a leftover, not going to choose. Base 7 is common for all, we are going to choose for all. Choose, right? So we can choose here. Yes, we are going to choose 3. Right? And then 5, we are not going to choose. 7, base with the lowest exponent. 7 once. And that 3 times 7. E21, fella. E21, E21, E21. Alright. Okay, the last 2, guys. The last 2. The last 2. So that I can go and... I'm hungry. Okay, the last 2. The last 2, guys. $130, $325, $845. Yeah, grade 9s can't be wasting their time doing ladder method. 130 is equal to shift fact, bam, product of prime factors. 320 is equal to shift fact, bam, product of prime factors. 845 is equal to shift fact, bam, product of factors. Then LCM, HCF, done. Because time is of the essence when writing exams. June exams, guys, when you write your June exams, that's another thing. Time is also going to be your nemesis. So that's why I'm saying some things need to not be done because other time needs to be devoted elsewhere. Hello, himself. Himself is here. Yeah, bro. Does that make sense? I hope it makes sense. So lowest prime number, 2. How many times does 2 go into 130? What's 130 divided by 2? Number 65. Smallest prime number that goes into 65. Moving very swiftly now. Moving very swiftly. Smallest prime number is 5. How many times does 5 go into 65? We're moving very swiftly now. 13. Smallest prime number goes into 13. How many times does 13 go into 13? Once. Smallest prime number that goes into 325. This is 325, by the way. 5. How many times does 5 go into 325? 65. You see, now you can see the same picture after that. Smallest prime that goes into 65. Of course, you can see because it's the same picture that you saw there. You see, same picture. I'm not gonna waste my time there. 845. Smallest prime number that goes into 845. Do you see why I'm continuing on? Because it's like, no, I'm just kidding, guys. I think I made a bit of a blunder. Oh no, it's not a blunder actually. I was just thinking out loud. Yeah, so it is the same picture. Same picture. Okay, 845. Smallest prime number? Yes, it's 5. How many times does 5 go into 845, guys? I am so hungry. It's not even funny. I think I could eat pickled fish. Isn't that like the customary dish that people are having right now? Pickled fish. Oh my soul, what in the world? Tsakeleke, 012 to the screen, tsakeleke, 012 to the screen. 5 goes into 845, 169 times. Smallest prime number that goes into 169. Don't worry, they'll tell you what pickled fish is, these people that are here. Yeah, the prime number is not between 1 and 10. Yes, Caden. 13. How many times does 13 go into 169? Or in other words, 169 divided by 13. It is 13. Smallest prime number that goes into 13 is 13, and then how many times once? So let's just 130 it, 325 it, and then 845 it. So we look at the product. We have 2 times 5 times 13. Single. For 325 we have 5 squared times 13, and then for the last one we have 5 times 13 squared. So for LCM, all right, we can see 5 is common for all and 13 is common for all. We go for the common base with what exponent? With the highest exponent. 2 is a leftover, so we write 2, of course, because it's a leftover. It's the only base. It has no friends. Base with the highest exponent where 5 is concerned is 5 squared, and then base 13, base with the highest exponent, is 13 squared. You can see most why we would write 2. 2 is a leftover. Stand alone. We put it in the mix. Leftovers are also part of the beautiful mix. Then you say 2 times the 25 times 169. All right, which then obviously will give you an answer of what, guys? 2 times 25 times 169 gives us a beautiful answer of, drum roll, is it the 8,450 that Caden says he thinks it is, or is it something else? Okay, Caden removes the I think, and in the affirmative says it's 8,450, which I think I agree with. Well, I don't think, I agree with. HCF. Yeah, the glory has been taken. Eh? Yeah, you see, guys, in life, there's always someone who will be faster, better, quicker, all right? And that shouldn't make us feel any less of anything, you know? It's just that that's just how life is, guys. That's just how life is. Okay. So don't take it too hardly. These things, they happen. That's life. That's how life humbles you. Anyways, HCF, highest common factor, common base. We only focus on the common for all. So we're not even thinking about 2, because a leftover we don't even consider. Even if 2 was common for 2 numbers, we wouldn't consider 2. For highest common factor, we are always looking at, are we common for all? Then we make a selection. And it's the base with the lowest exponent. So 5 we are going to take, 13 we are going to take, 65 is going to be the answer. Indeed, it is the highest common factor. Okay. Thank you, people. This is beautiful. Let's look at this last one, man. Yo, we've been pushing highest common factor. Right, I'm gonna upload this onto my YouTube channel once we're done, so that people that want to recap, revise, look at, and just remind themselves of certain things, they can always go and recap, look back, and all of that stuff, and they can hear their names being called. And I expect all of you to at least watch even if it's like 20 seconds of the video, so that I can get views on the video once I've uploaded it there. Okay, grade 8. YouTube channel link is in my bio. It's also called Maths is a Game. White profile picture, guys. Maths is a Game. White profile picture. Link is in my bio. So if you go to my homepage, the link is there. It's in the bio. Maths is a Game. 5 to 7. That's it. Right? Okay, I'm gonna shortcut this one, because hey guys, you don't understand. I know you would all do ladder method. 693 equal to shift, then boom, fact. 3 squared times 7 times 11. That's 693. 3 squared times 7 times 11. 1617 equal to shift, then fact. 3 times 7 squared times 11. 3 times 7 squared times 11, that is 1617. Then lastly, 2541. 2541 equal to shift, then fact. 3 times 7 times 11 squared. So do you see here? We are having the emergence of common for all, common for all, common for all. So basically no leftovers, which is great. So all I'm going to be looking at is the base with the highest exponent. So from 3, who am I going to select? 3 squared. From 7, who am I going to select? The base with the highest exponent. That is, yes, chappy, 7 squared. Then from base 11, who am I going to select? You see, 11 squared. And then can go after that. It's all to the maths to be done. 9 times 49 times 129. 9 times 49 times 121 times 121. I get 53,361. Okay. Nine times 49 times 121. It is 53,361. That is the lowest common multiple. 53,361. Huge lowest common multiple. Highest common factor has to be common for all the bases, but we choose the common base for all that has the lowest exponent. So lowest exponent there for base 3, right? Base 3, who are we choosing for base 3, guys? That has the lowest exponent. It's 3, right? Then for base 7, who are we choosing that has the lowest exponent? Base 7, right? And then lastly, 11, base 11, who are we choosing? Who has the lowest exponent? It's times 11, right? And from there, 3 times 7 times 11. We are getting the answer. God, 2KD1. Yes. So our friend was all right, okay, from the get-go that it is the answer. Okay. Yeah. Yeah, guys. So this is beautiful. All right. So yeah. All right. Just there for the purpose of things to know, guys. These are things we need to know forever as math students in high school. We need to always know what a whole number is. That a whole number has this symbol, the N with the O. This is like the symbolic representation of whole number. Whole numbers are numbers that start at 0, they increase by 1 all the way to infinity. We need to know the commutative property of addition, that a plus b is equal to b plus a. The order of numbers when you are adding doesn't matter. You'll still get the same answer. 1 plus 2 is the same thing as 2 plus 1. The commutative property of multiplication, we need never forget it. No, a times b is equal to b times a. Like the order in which you place numbers when you are multiplying doesn't matter. You'll still get the same answer. So these properties, commutative property, apply only to addition and multiplication. They don't apply to subtraction and division. And that's something you need to know. All right. Thank you so much for the hot Mizi. Then there's the associative property of addition. The word associate means when you group. All right. So if you have things added, right, left and right. Let's say you are adding 3 things on the left, you are adding 3 things on the right. You can group the first 2 in brackets. Grouping the first 2 or grouping the last 2 does not lead to a different answer if it's addition that you have throughout. All right. So we call this the associative property of addition. A plus B plus C, you group B, A plus B, is no different from A plus B plus C if you choose to group or put in brackets the last 2 terms. Okay. So the associative property of addition, there's also the associative property of multiplication, because for multiplication we can do the same. But guys, for subtraction, you can't do it. For division, you can't do it. For a mix of operations, we don't do it. There's only the associative property of addition and only the associative property of multiplication and nothing else. So commutative property applies for addition and multiplication. Associative property applies for addition and multiplication. Please, guys. Then there's what we call the distributive property of multiplication over addition. Okay. You have A here, you have a bracket, you have B plus C. You take A, you distribute it. By distributing, it means you multiply A times B. That's why in brackets you have A times B here. But you distribute A to C over the addition sign. So you put the plus sign, then A times C. You see, we are distributing A to B and C over addition. So that's why we call it the distributive property of multiplication, because when we distribute, we multiply, but we are multiplying over addition. We can also do it over subtraction. So the distributive property of multiplication can be applied over addition and subtraction. Okay? It works over addition and subtraction. Distributing is only done over addition and subtraction. It is not done over multiplication and over division. No, 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 no. The distributive property of multiplication is only done over addition and subtraction. When you know these things, guys, these are foundational things, man, for the maths that comes in grade 10, 11, and 12. Learners are not struggling with maths sometimes because of the topics that are taught in higher grades. No, they are struggling because they don't understand the foundational roots where the maths comes from. And that's problematic, it's so problematic. The mathematics stays longer in a learner's mind and heart when they know the roots of where the things come from. When you have deep understanding, conceptual deep understanding of maths, then it makes maths easy to do and it makes the understanding flow. You see? So yeah, Then we say we usually say that addition and subtraction are inverse operations. The word inverse means opposite. So addition and subtraction are opposite operations. For instance, if A plus B is equal to C, then we can say C, which is this, minus B is equal to A. In other words, you take the B over the positive B becomes negative B. Now you have C minus B, which is equal to what? To A. Or you can say C, you take the A over, you leave the B. The sign changes to negative. So you can say C minus A is equal to B. So these are what we call inverse operations. Okay? Inverse operations. Inverse. And more specifically, when it's dealing with addition and subtraction, we talk about what we call the additive inverse. Okay? The opposite to addition is subtraction. Then multiplication and division are also inverse operations. If A times B is equal to C, then we can say C divided by the B is equal to A. All right? Yeah. Because A is being multiplied to B, the opposite of multiplication is division. So you can say C divided by B is equal to A. Or you can say C divided by A is equal to B. Right? That's maths. That is maths, the inverse operations. Multiplication and division are inverse operations. Addition and subtraction are inverse operations. Then I wish to say the following as well. In your operations, addition, subtraction, multiplication, and division, you have what you call your mathematical operation separators. Plus and minus separate terms, but division and multiplication combine terms. So we have separators and combiners. Who separates? Addition and subtraction. Who combines? Multiplication and division. All right. Yeah. So, yeah, man. And please know your numbers, man. Know what an even number is. Okay. An even number is any number that is perfectly divisible by 2. Even numbers, they end in the following numbers. You will know a number is even if it ends in 0, ends in 2, ends in 4, ends in 6, or ends in 8. Okay? I hope it makes sense. And so an even number can be split into 2 equal whole groups. That's why we say it's even, because you can split an even number into 2 equal whole groups. 4 can be split into 2 and 2. 8 can be split into 4 and 4. Basically, even numbers can be split into 2 equal whole groups. That's even numbers. Okay, perfectly divisible by 2, those numbers. And 0 is the smallest even number. That's another thing people don't note, that 0 is actually even. Okay, it's an even number. 0 is an even number. Odd numbers. Okay, these are numbers that are not divisible by 2. They always leave a remainder of 1. But they end in the following numbers. They end in 1, in 3, in 5, in 7, and 9. That's how you know that it's an odd number. The minute you can see that that particular number that you have before you, it ends in 1, 3, 5, 7, or 9, then you know it's an odd number. The minute you know it ends in 0, 2, 4, 6, or 8, then you know it's an even number. So we need to be able to distinguish between what an odd number is and what an even number is. Okay, then here's something else. Okay, I picked this up when I was doing the live lesson yesterday. I was like, hey, some people don't know certain things. That's why I'm emphasizing them. 0, guys, is what we call an identity element. For what? For addition. The word identity. Think about your own identity. Okay, your identity is everything. People nowadays are always asking themselves, who am I? Where do I come from? Where will I go after this life, if even there's even a life after this one? Identity is a big thing, because some people can't function without their identity. Some people, they basically get destroyed because they don't know who they are. What I'm saying in essence is that identity is something that is important, because it's tied into who you are, right? So for instance, T is T, right? The letter T is T. We say that 0 is what we call the identity element for addition. So what t is will remain as t if you add t to 0, because 0, what 0 is that 0 when added to anything does not change that thing. So who you are does not change with 0. You retain your identity with 0. If you are added to 0, you remain as who you are. For instance, 1 of me plus 0 of something else means me. Okay? 5 plus 0 is 5. 10 plus 0 is 10. 2 plus 0 is 0. 1 million plus 0 is 0. 1 million plus 0 is 1 million, sorry. So what I'm saying is that whatever is added to 0 retains its identity. It does not lose its identity. So the number added to 0 remains that number. So we say, therefore, that 0 is called a what? It's an identity element, but only for the operation of addition. It's an identity element. What about the number 1? 1 is also an identity element, but it is an identity element not for addition, because if you add 1 to anything, it changes, right? So that means it's a change of identity in the number that was there. But 1 is an identity element for multiplication. You see? So you have 0, who is an identity element for addition, but then you have 1, which is an identity element for multiplication. What happens when you multiply a number by 1? That number stays as it is. In other words, that number does not lose its identity. So 1, guys, is called an identity element for what? For multiplication. 0 is an identity element for addition. All right. And these are things that are important when dealing with numbers, things that one needs to know. All right, just for knowledge and depth of understanding, for your maths, for yourself. Okay, so different types of numbers. We have whole numbers, start at 0, increase by 1 to infinity. Those are whole numbers. That's the family of whole numbers. Start at 0, increase by 1 to infinity. Natural numbers, they don't start at 0, they start at 1, increase by 1 to infinity. Even numbers, we spoke about them. Okay, odd numbers, we spoke about them. Okay, then when we talk about additive inverse of a number, okay, if I say to you, what is the additive inverse of 5? What is the additive inverse of 5? So inverse means opposite. And the minute I say additive inverse, when I am thinking about the opposite of the number that I am giving to you. If we saying 5 is positive, what is the opposite of positive? The opposite of positive is negative. So therefore the additive inverse of positive 5 is what? Is negative 5. Because we are looking for that number that when we add to 5 will basically give us 0. So an additive inverse, its only role or responsibility is that we take a number plus its opposite, which will give us 0. That number added to its opposite should give us what? 0. So the additive inverse of 5 is minus 5. The additive inverse of minus 5 is plus 5. So that's what we mean by additive inverse. That number that will add to the given number that will give us 0. That's called an additive inverse. And when we are solving linear equations, we use the concept of additive inverse to get rid of a constant term or to eliminate a constant term in an equation. Okay. Then we have a multiplicative inverse, which is a number multiplied by its reciprocal, which will then equal to 1. So if I ask you what is the multiplicative inverse of 5, then you know the multiplicative inverse of 5 is 1 over 5. What would you divide 5 by to get 1? You divide it by 5, right? But what is that division of 5? It is actually a multiplication of 1 over 5. Where is that 5 that you see there? It is in the denominator. Okay, So what I'm saying, if I ask you what is the multiplicative inverse of 1 over 5, then you can tell me the multiplicative inverse of 1 over 5 is 5. But if I ask you what is the multiplicative inverse of 5, then you can tell me the multiplicative inverse of 5 is 1 over 5. Because what am I looking for when I'm talking about the multiplicative inverse? Multiplicative inverse of a number is a number multiplied by its reciprocal to give us equal to 1. Okay? So the multiplicative inverse of 5 is 1 over 5. Okay? If I ask what is the multiplicative inverse of 2 over 3, then it is 3 over 2. All we do is we swap around 2 over 3, we write 3 over 2. This is the multiplicative inverse of who? Of 2 over 3. What is the multiplicative inverse of 1 over 8? Okay, what is the multiplicative inverse of 1 over 8? The multiplicative inverse of 1 over 8. What would you guys say? Chat. Multiplicative inverse of 1 over 8. What is the multiplicative inverse of 1 over 8? You would say the answer is what exactly? Exactly, it would be 8, right? Very, very true. Remember, 8 over 1, the same thing as 8. But I really appreciate the fact that you are writing 8 over 1, because that means you get the concept behind this idea of multiplicative inverse. So when they ask you such a question, because grade 8 and 9, they ask that question like nobody's business. They will just ask you, what is the additive inverse of a particular number? And then some of you don't know. Right? So if I had asked, okay, let's leave multiplicative inverse, let's go back to additive inverse. If I had asked what is the additive inverse of -7, what would you guys say? The additive, not multiplicative inverse, but the additive inverse of -7. What is the additive inverse of -7? The additive inverse of -7. Keza, thank you. Z, thank you. Appreciate it. So I guess everybody else that's coming after you guys understands the concept. Okay, additive inverse. If you have a negative sign, it means the answer you are going to write is not going to be negative, but it is going to be positive. And then last but not least, the answer is then obviously going to be 7. Okay, positive 7. What is the multiplicative inverse of -1 over 3? What is the multiplicative inverse of -1 over 3? Multiplicative inverse of -1 over 3. Wonder boy, thank you. Thank you. Thank you. Wonder boy, wonder boy, wonder boy. Thank you. Guys, be careful here. Negative. Remember, you want an answer that is going to give you +1. So a negative times what gives you a positive? It has to be another negative, but then the inverse of 1 over 3, 3 over 1. Be careful when I give you a negative sign and I ask you the multiplicative inverse. Okay. Yes, but what you are noticing here is that if I say the multiplicative inverse of 5, same sign has to be 1 over 5. Now, if I say multiplicative inverse of -1 over 3, still same sign, so that I can get a positive answer. Same signs multiplied give us a positive. Same two signs multiplied give us a positive. Same two signs multiplied give us a positive. Same two signs multiplied give us a positive. So a negative times a negative gives you a positive, just like a positive times a positive gives you a positive. Same two signs multiplied give us a positive. Same two signs multiplied give us a positive. So that's just something to make sure that you always remember. Factors. Guys, a factor. You see, we talk about highest common factor, but at the foundation, what is a factor of a number? Yeah. So when I write down the factors of 12, what am I actually talking about? Factors of numbers, these are numbers that divide exactly into the given whole number. These are numbers that divide exactly. They are exactly divisible. They don't leave a remainder. You can take those numbers, shove them into another number. They will not leave a remainder. You can fit them into another number without leaving a remainder. So for instance, the factors of 12, the numbers that fit into 12 without leaving a remainder are 1, 2, 3, 4, 6, and 12. You see, these numbers fit in perfectly into 12 and don't leave a remainder. How many times does 1 fit in? 1 fits in 12 times. How many times does 2 fit in? 2 fits in 6 times. How many times does 3 fit in exactly into 12? It fits in 4 times. You see, so these are numbers that fit in exactly into another number. That's what a factor is. So the minute I say to you, what is the highest common factor, then I'm looking for the number between numbers that I am given that is basically the best fit into those two numbers. But it must be the highest. It can't be just a fit. It must be the highest number that fits. All right? So it's very important. Factors, understanding what a factor is. Multiples, because we speak of terms, but I don't know if we really, capture the essence. Multiples of a number. Numbers obtained if the number is multiplied by the natural numbers. Numbers obtained if the number is multiplied by natural numbers. So for instance, 3. If I say, what are the multiples of 3? Say 3, 6, 9, 12, 15, 18, 21, 24, 27. Guys, what you are doing is that every number you actually are saying is a number multiplied by your consecutive natural numbers. Natural numbers are numbers that start at 1, increase by 1 to infinity. So 3, you are multiplying by 1, you get 3. 6, you are multiplying by 2. 9, you are multiplying by 3. 12, 3, you are multiplying by 4. You see, so all these are what we call multiples. Okay, please guys, then we ask, what is the lowest common multiple between numbers? Guys, you must understand what we are talking about. Prime numbers. A prime number is a number with only 2. Oh, look at that. Sometimes I doodle when I get very bored. I don't know if you guys do this, but I do this a lot. It's like I'm bored doing something and I start doodling. Okay, and then something like this comes out and I'm like, what in the world? Prime numbers. Prime number is a number with only 2 factors, 1 and the number itself. Okay, there we have that list of prime numbers. Okay, listing the prime numbers between 1 to a little bit over 100. Look at them. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97, 101, 107, 109, 113. These are all the prime numbers that are between. Okay, but obviously guys, it's nice to know the prime numbers, at least the ones between 1 and 100. Okay, so that when you are needing to, such can be identified. Here's something to note. 1, the number 1 is not a prime number because it has only one factor, namely itself. So 1 is not a prime number. Okay, please guys, please. Then composite numbers. Composite numbers have more than 2 factors. Composite numbers have more than 2 factors. Example, 6 is a composite number. Why? Because factors of 6 are what? We have 1, we have 2, we have 3, we have 6. So 6 is not a prime number. 6 is a composite number. So we say composite numbers and prime numbers are opposites of each other. Okay? Yeah. 1, on the other hand, is neither a composite number, neither is it a prime number. 1 is just 1. It's not a prime number. It's not a composite number. So don't categorize it under any of these two, composite or prime. Okay? Then sometimes you get asked to identify prime factors of a number. Okay? Prime factors of a particular number are the factors of the number that are also prime numbers. Okay, so if I give you the factors of 12, for instance, as you see here, the factors of 12 are all of them here. But then I say, what are the prime factors of 12? Then it is those numbers in these factors that are actually prime numbers. So if I had said, what are the prime factors of 12? Then all we do is we identify 2 and we identify 3 because those are the only prime numbers in these factors. So we'd say that the prime factors of 12 are 2 and 3. Okay. So we need to be people that are able to do such things, identify prime numbers when the need arises. Okay, guys, I'm going to hold it right there for today because ratio and rate will be the next thing that I'll be doing for my beloved grade 8s and 9s. These guys are just meaty sessions that I want to do for grade 8 and 9 so that when they want to revise, they can go to my YouTube channel and they can go back and see, oh, we did this before. And yeah, there can be something that is meaty for them so that they can have an understanding. I know grade 8s and 9s don't like big lessons, that are long and stuff, but it helps though to have such so that you can have a depth of understanding. So I'm doing this for them, the grade 8s and 9s, because the solid your roots are in maths for grade 8 and 9, the easier the maths is in higher grades, grade 10, 11, and 12. And you can then choose pure maths and not necessarily gravitate to the easier choice, maths lead. Okay. Otherwise, guys, thank you so much. Let me love and leave you. It was great. I am crazy hungry. It's insane. Let me love and leave you. Let me see you when I see you. You guys have been an amazing audience. Let me give you a round of applause. Round of applause to you guys. You've been here for the longest time. Like, it's so amazing. Like, one more round of applause. You guys have been amazing. You've been phenomenal. You've been amazing and stuff. Like, you guys truly make my heart skip a beat. Like, yeah, see, like it skips a serious beat right now. Like, it's insane. Yeah, thank you so much, Jay. You guys stay amazing, stay awesome, and I'll see you again whenever that is. Cheers.